Welcome to lecture 26. In this lecture, we will be interfacing LDR with STM board. LDR is light dependent resistor. Okay. So, we will be first looking into what is LDR. When you connect an LDR, what all things you should take into consideration, and of course, the circuit diagram to perform the experiment with LDR. The first experiment, we will be doing two experiments. First experiment with LDR, I will show the circuit diagram and I will discuss the code, and finally I will demonstrate it. Okay. So, as I said, we will discuss the LDR interfacing circuit. In this experiment, we will be sensing the ambient light level and will change the intensity through PWM port of an LED, and will show the demonstration. Firstly, coming to what is light dependent resistor. It is a variable resistor which is a passive component whose resistance value changes depending upon the amount of light falling on it. Okay. So, whenever light falls on it, its resistance value changes. How it changes? More the amount of light, less will be the resistance, and vice versa. So, if the light is more light falls into the device, then its resistance decreases, and if less light falls on it, that means if it is dark, then the resistance value will be high. The variation of this resistance with light intensity is non-linear. Like for LM35, we have seen that with 10 millivolt change, there is a degree centigrade increase in temperature. So, there was a linear change. Here, that is not there. Okay. So, the variation of the resistance with light intensity is not linear. A simple resistance divider can generate an analog voltage that depends on the resistance of this LDR. So, this is a typical diagram. This is an LDR, how it looks like. When we do the experiment, we will show you in more detail. This is an LDR, okay, and you see that one port is connected with 5 volt, another port through a resistance is connected to ground. Okay. So, I repeat, one point of the LDR is connected to 5 volt, another point is connected through a resistance to ground, and the voltage output from where we are taking is from here. Here we are connecting to the analog input. This is how the connection goes. Now, let us see this LDR interfacing. We need to first test the LDR by measuring its resistance. See, in this room there is an ambient light. Okay. Maybe in another room the intensity of this light might be different, right. So, depending on that, at what value this LDR will change its state, or LDR will work upon depending on the application we are thinking of. It is dependent on all these parameters. So, you see this, so we consider this, the resistance of LDR when there is no light is 150 kilo, and when there is light it is 10 kilo ohm. Let us say this is what we are getting, but you have to take this and take the reading using a multimeter, and then only you can do this experiment. Let us say we have taken and we got a value in this range. Now from 5 volt, this is the LDR which is connected, one end of it, and then resistance R1, it is connected through ground, and from here we are getting V out. So what will be the current flowing through it? Current will be V equals to IR. I will be V divided by R. So V divided by resistance of this LDR plus R1. What will be V out here? V out here will be I into this particular resistance. What is I? I we have already calculated, V divided by R LDR plus R1, and this is multiplied with R1. Okay. So if V is 5 volt, then it is 5 multiplied by R1 divided by R LDR plus R1. Okay. Now based on this particular condition, okay, we will be looking into what kind of values will be, how do we choose this particular R1, okay, depending on the previous calculation that we have already made. So within the range of light intensity for some application, the variation in output voltage should be appreciable, because I want that variation should be more. Okay. When there is light and when there is no light, we need to choose that R1 in such a fashion that that is quite visible. Okay. So consider for example this consider for this example, let us say R LDR, resistance of this LDR is 150 kilo ohm, and R LDR 10 kilo ohm when there is light, and when there is no light 150 kilo ohm, and we put it in this particular formula to calculate V out for light and V out for no light when R1 is 1 kilo ohm. So R1 we already know, then R1 for light, so with 10 kilo ohm we got this value, and V out with no light with this particular kilo ohm as R LDR, we get this value. Okay. So depending on that, you can actually calculate for 5 kilo ohm as well, which is coming down to 1.67 volt, and for no light it is coming to 0.16 volt. So you can actually work out for all the values by putting the value of R1 as 1 kilo ohm here, and R LDR when there is light 10 kilo ohm, and when there is no light 150 kilo ohm, and you find out what value you are getting for this V out. You see that for 20 kilo ohm the range is, it is 3.33 and this is 0.56, which is considerable, because when it is 50 kilo ohm it is 4, but it is also becoming 1.25. Okay. So how do you choose this value of R1 is somewhat important. Please take this into consideration, and you can do this calculation by using a multimeter to read the value of this R1 and LDR value depending on light and no light, and then you can work out this example. So if you see the nonlinear variation of the resistance with light, so when it is dark its resistance is high, and when it is dark its resistance is high, and slowly its resistance decreases. Okay. When there is light the resistance is low. So the experiment that we will be doing today is, will create a room light controller using LDR, and will sense the ambient light and adjust the intensity of the room light accordingly. So how do you simulate here? For simulation purpose we have just used an LDR. we have used an external LDR that will be connecting with this STM board, and depending on the ambient light, okay, the LED will glow fully, or if the light is little bit, if the light is very bright, then the LED will not glow, and if the light is little bright, the LED will glow but very lightly, okay, and there is no light, then the LED will glow, okay. So, let us see, for demonstration what we have done, basically we use an LDR circuit connected to the analog input pin A1. So, instead of a bulb, as I said, we are using an LED that is connected to the PWM digital output pin D2. We have already discussed specifically what is PWM pin, what are the functions that are attached to the PWM pin, what we can do through that PWM pin. So, in this case we will be using one of the PWM pin to glow the LED to full intensity with little less intensity, and will off it, okay. The duty cycle of the PWM signal is varied depending on the level of the light. Depending on what level of the light we are having, we will change the duty cycle. In the experiment, we defined 3 levels with corresponding duty cycle of 1, 0.8 and off. These are the 3 things that we have used, and the LED will glow when, which is connected to D3 port, when this is 0. Okay. So, we will take the experiment that we will be doing, we need to take the following things into consideration. Next, how are the threshold values determined? So, the threshold values that we have determined here have been fixed through experimentation. We did quite an experiment and we find out that what is the best value that will help that LED to take the following things into consideration that we wanted in this ambient light thing. The analog input voltage read from LDR outputs in the range of 0 to 1, which is multiplied by 5000 to make it to some point such that we can find out what is light and what is no light. The 3 threshold ranges are fixed at 200, 500 and 850. These are the 3 ranges that we have kept, and this less than 200 PWM duty cycle will be 0, okay. And if it is 500 and 850, we change it accordingly, okay. Now, this is the circuit diagram. Circuit diagram is fairly straightforward here. This is a single LDR. One end of the LDR is connected to 5 volt. Another end of the LDR through a resistance is connected to ground. So, this is one end of the LDR which is connected to this 5 volt. Another end of the LDR through this resistance is connected to ground. And the analog value that we are taking input is from this point to port A1, and as I said, the LED that to simulate a bulb, basically we are using LED. So, the LED, this is the anode which is connected through a resistance to 5 volt, and the cathode is connected to port D3, it is connected to D3. So, if this value is 0, then the LED will glow, okay. But now we have to see, it is D3 is the PWM pin. So, we have to make sure that it glows with full intensity or with little less intensity, and it will be off, okay. So, this is the circuit diagram. Now, let us move to the code. This is the code. Now, PWM out LED D3. So, this is connected to this LED, which is not only a digital output pin, we are using this pin as PWM out pin. That is why instead of just digital out, we have specified PWM out LED, which is this D3 pin of the board. Analog in, my in, I have given the name, which is connected to A1 input of the analog port. Float, we have taken value, then an integer value. In the while loop, what we are doing, we are reading with the same function that we have read for temperature, my in dot read. Then I am multiplying this into 5000, and then if this value is greater than 850, then I am making that LED on. If it is greater than 500 and less than 850, then I am glowing it, but not with full intensity, with 0.8. Okay? And if it is less than 200, I am making it off. So, these are the 3 levels that we have made for this LED. What we are outputting? We are outputting to this LED, which is the PWM port. We are putting 1, fully it will glow. 0.8, it will glow for 0.8 and off for 2 seconds. And this will be totally off. Okay? So, these are the 3 levels that we have shown. Okay. So, what we'll do now is that whatever I have told you, I will be showing you the interfacing part. And in the interfacing part, firstly I will tell you how this LDR value changes depending on the light that we have in the ambient light, depending on the ambient light. Okay. So, and depending on that we have to make our code accordingly. So, that is the calibration you have to do at the first step. Okay. Let us now look into the interfacing, that is the demonstration of this experiment. Now, I will be showing you the experiment with LDR. LDR is light dependent resistor. So, the experiment that I will be showing you today is that depending on ambient light, we will see that how we can change the intensity of the light glow. Let us say when the ambient light is full, the light will not glow. When the ambient light is little less, the light will glow, but not glow with full intensity. And when the ambient light is really very down, that means it is dark, then the light will glow to its full intensity. So, to do the experiment, we have taken an LDR and an LED. So, the LED will glow in 3 levels. At one time it will not glow when the ambient light is high. When the ambient light is little less, it will glow, but it will not glow with its full intensity. And when the ambient light is very less, it will glow with full intensity. So, we will do that experiment. Prior to that, I will be telling you about the property of this LDR. LDR is light dependent resistor. So, its resistor changes dependent on the light, that I have already discussed, but I will see that with this particular ambient light that we have it in this room, what value I will be receiving it in the multimeter for this LDR, and then I will make this ambient light little dark, and then what value I will receive. So, you will understand that when you do this experiment, you have to take this particular scenario into consideration. Okay? Okay. So, first of all, I will now show you. So, this is an LDR. Okay? So, and this is the multimeter. Now, we will see that what value this will give when we connect using this particular ambient light that we have. Okay? So, let us see. So, what value it is giving? It is giving around 29, let us say. And now see, I will put my hand. So, I will put my hand. You see that the resistor value changes. Okay, it is going up till say 130 or so. Again I take out, it will settle down to let us say 29. Okay. So, this is depending, this value that we are receiving here is dependent on the ambient light. Okay. Now, I will make this ambient light of this room little bit dimmer. Okay. Okay. And now, let us see what value I will be getting. Now, you see that the value initially I was getting 29 when there was full light, and now we are getting a value about 41 or 42, let us say 41.7. Okay. Now, when I put my hand there, okay. So, when I put my hand, the value goes up till let us say 77, 100 and let us say 100, it is going 115 sometime. So, this particular thing you have to incorporate in your code. So, in the code, so this is how basically you have to look into it. Okay. Okay. Now, again you see with the full bright light it is coming 29.5. Okay. So, this is a property of this LDR. Okay. So, now I will be showing you the experiment as I said with LDR, but one thing you have to remember that so the value of this particular LDR changes dependent on the ambient light. When you incorporate your code, when you try to design something with LDR, you have to take into consideration these few things. Okay. So, what is the ambient light, and depending on that you have to change your code or anything. So, now I will, the experiment that I will be doing is this LDR will be sensing the ambient light, and depending on that, if the ambient light is little dim, then the LED will glow to certain extent, but it will not glow fully. But if the ambient light is very light, there is no light, then the LED will glow to its fullest. Okay. So, I will do the connection. See, let us see how I make the connection. This is LDR. One end of the LDR I will be connecting to BCC. Another end of the LDR through a resistance I will be connecting it to ground. And you see from this point, so please understand from which point, from this point, from the point where I am connecting this LDR through this resistance to ground, I will be taking from this point to the analog input. Okay. So, please make this connection clear. Two ends of the LDR, okay. One end I will be connecting it to BCC, another end through a resistor I will be connecting it to ground, and from this end I will be taking the input to the analog port. And this LED is straightforward. LED, we are connecting this anode using this resistance to BCC. So, this is connected this way, and the cathode will be connected to the PWM port D3. Okay. So, the PWM port, as we already know, already been discussed that what we are doing with PWM. So, we are connecting there because we need this LED to be glown with different intensity. Okay. So, let me do the connection with STM board first. So, this, as I said, will be connected to A1. This point is connected to BCC. And this point will be connected to your ground. Okay. And from this point, that is the cathode of this LED, will be connecting it to the PWM D3 port. Okay. So, this is all about the connection we need to do when we do this experiment using LDR intensity. So, changing the intensity of the light depending on the ambient light. Okay. So, now I will dump the code that I have already discussed with you once the connection is all right. Okay. So, let me dump the code. Okay. Now, the code has been dumped. Okay. Now, see, the LDR here is receiving full intensity. Now, I will decrease the intensity little bit. Now, see, I have decreased the intensity, so it is glowing, but it is not glowing with full intensity. When I put entirely dark, when the ambient light goes down to, the light inside this room becomes really dark, then the LED is glowing in its full fledged. Let us see again. Now, the LED is glowing, not glowing at all. Okay. Now, see, when it glows when there is less ambient light. Now, it is glowing in full fledged when the ambient light is completely very less. Okay. So, this is the experiment with LDR. By getting the ambient light, how do we actually switch on the light with different intensity. So, this we have simulated using this LDR. So, I just will show you once more. So, this is glowing, but not with full intensity, but you see this is glowing with full intensity. Okay. So, in this experiment, we basically have shown you how you will connect LDR with STM board, and depending on the ambient light, how you can actually do some kind of operation. Here we have done using this LED. We have made the LED glow with 3 different levels. When the ambient light is full, it will not glow. When the ambient light is little less, it will glow, but not with full intensity. And at one level, when the ambient light is very less, then it will glow with full intensity. Thank you.